And you are our first speaker, so I will give a brief introduction and then I'll
Okay.
bring you on.
And Marika, can you see anything I'm presenting yet?
I cannot right this moment.
Okay, interesting.
Good morning.
Morning.
Good morning. My name is Marco Robertson, and I am with ATARC, and we are partnering with Tradewin to help them coordinate and host this event today. We are here in the joint logistics track of the Tradewin Member Showcase, Navy Edition. Thank you for joining us. And in this track, we have a total of 8 presenters with 5-minute breaks built in between. We have a very tight schedule today, and also because this is an actual competition situation, we will be very strict with sticking to those time limits, so please do be mindful of that. Without further ado, our first presenter is PMAT Inc., and our speaker is John Kilgore. So take it away, John.
Thank you. Can you hear me all right? And can folks see my screen? Can I get a check on either of those? Hello? Hello, can anybody hear me? All right, I will try this one more time. Apologize, when I'm sharing my screen, I can't see the comments that are coming up. All right, so we will do this and hope for the best. So my name is John Kilgore. I'm the Director of Science and Technology at PMAT Incorporated, and excited to talk to you today about some concepts and kind of vetted requirements and capabilities around contested logistics specifically. So just a little bit about us. We are a small business. We were founded in 2007. Our major offices are in Norfolk, Virginia, DC metro area, Denver, Colorado, and San Diego. In terms of what we typically provide, we are a software development and data management company. We are delivering actual microservices, architecture, and solutions to the Navy today. We also have mature DevSecOps pipelines. And really, our focus is around managing data and then exploiting that data through techniques such as AI/ML. Just a little bit about our focus areas. Again, we're really trying to help the Navy, Marine Corps, as well as the Coast Guard solve some of the challenges around data saturation and help to automate the process of decision making, enabling decision dominance as well. So in terms of, you're going to see a lot of kind of C2, ISR kind of focus areas, but we believe there's a theme there that really involves contested logistics. And we would like to fill that niche because it could really make the difference in a near peer or peer adversary type situation. And hopefully everyone here being interested in logistics also realizes that logistics is critical, especially as you get into potential conflicts further and further away from home. So this slide is really just about our capabilities. On the left-hand side, you could consider those to kind of be our enablers. And on the right side, it's kind of, what are we trying to impact? What are the outcomes we're trying to reach? So I've already spoken a little bit about we develop user interfaces, we develop kind of data management, data lake and data warehouse solutions. And then as those have matured, of course, then the questions start to become, okay, how do we better use the data? What problems can we solve with the data? And then how do we try to reduce operator workloads in order to automate processes and be able to make critical decisions faster, giving us the advantage? All right, so now we'll get into something a little bit more logistics specific. So, PMAT being a small business, we're kind of a non-traditional contractor by default, but we're also kind of non-traditional within the logistics space. But through our C2 common operating picture, shared situational awareness solutions, we've developed some key relationships with organizations such as Military Sea Lift Command. Admiral Wetlaufer, the commanding officer there, actually uses some of our shared situational awareness solutions on an almost daily basis. We've conducted operations research with his organization and his staff. And then some of these concepts have also been vetted through kind of joint discussions with OpNav as well. So there's really kind of two themes to what we're trying to help try to solve for the Navy and Marine Corps. And the first theme there is really about trying to better protect logistics platforms and increase the survivability. So one of the things we see is we believe that there is too much of silos between kind of the C2 and fleet logistics communities, and we would like to be part of the solution to help break down those silos. And the way we want to do that is we want to better inform joint assets and help them help protect those by modernizing the logistic platform and infrastructure capabilities, specifically as it relates to shared situational awareness. We also want to integrate real-time C2 and smart logistics into common operating pictures, and I'll actually briefly show one of our existing solutions and how that could come to be. Something else we're also very interested in is we have already successfully performed some experiments showing how you can push critical information to the edge when units are operating in emissions control modes. The second kind of big theme is then along kind of more specific problems in terms of analytics and automating analysis, and then providing either automated courses of action or recommendations. So in terms of automated and accelerated decision making, it's about predictive logistics and maintenance forecasting and integrating that into like a common operating picture, automating and visualizing, reporting and tracking, everything from readiness, we've talked to MSC about, as well as things like platform health and status, cargo that's being transferred, even things like CAS reps and move reps. So kind of moving on that, just sort of a quick little plug. So PMAT, again, we've been in business since 2007. We have a history of success of taking, kind of science and technology projects and then advancing those to actually become transitioned to programs of records. You'll see examples here, everything from Magic Mirror, which was transitioned to the JWICS environment, to SAVA, which ended up being transitioned to DSIGS in Inc. #2. Minotaur Web, which is still in use today and continues to receive investment from a variety of programs, um, as well as some of our data lake and data warehouse solutions. So it's really been an evolutionary process where we've kind of gone from kind of curating and performing data management all the way from the unclassed level to the TSSCI level and cloud-based solutions, now to moving into AI/ML and how do we exploit that data and help users better get value from the data itself. So here are a few of our what I'd call foundational capabilities. Most of these are not specific to logistics, but they are kind of foundational capabilities that can be modified and leveraged and reused to support logistics specific use cases. So the first two, Xcap and Minotaur Reach, these are cloud-based data lake and data warehouse solutions, GovCloud, operating in GovCloud, SC2S, as well as C2S. They are microservices. Uh, versioned 1.0 for Xcap, for instance, is TRL9. We just delivered version 2.0 to the Navy for this, so it's currently in testing. So we have that at TRL 7. And both of these solutions are about bringing disparate data sources together and integrating them, and then providing basically common situational awareness pictures and common operating pictures. Minotaur Web is a thin client web-based global user interface. It's used at the TS level all the way down to the unclassed level. We'll look at that briefly. And we believe that Minotaur Web could be updated and modified to then also show logistics information in conjunction with that shared situational awareness. Tentacle is of interest because this is an example of us pushing data to the far edge. This is going out to the F-18 into a cockpit knee board or tablet. And then MSA Dark is an AI/ML project we'll talk briefly. This is funded by ONR, and we'll talk about that more here in detail in just a moment. So just a little bit more information about Xcap. Again, this is a multi-level security cloud-based solution operating in GovCloud, SC2S, and C2S. You can see on the left-hand side, we're ingesting everything from national data sources to tactical data right off the platforms, combat system data, METOC data. And then you kind of have there in the bottom left, which is a desire by MSC and OpNav to then also start to integrate logistics information in here to answer needs around things like predictive logistics and maintenance forecasting. This data lake and data warehouse is supporting missions from things like EP3 and P8. It's in the Aegis virtual twin. It also supports C2 centers and Intel centers. This is attribute level role-based access. Obviously, that's very important for something that's supporting so many classification domains. It's also near real-time and near real-time processing. And again, this is all a microservices architecture. So in terms of adding new capability and functionality, it can be done at a fraction of the cost and far faster than kind of traditional monolithic solutions. This is about shared situation awareness in contested environments. And this was an experiment that was done with military Sea Lift Command last year. So we're talking a logistics platform. And basically what we were able to demonstrate is that we can deliver critical information between a facility out in San Diego, California, to a ship off the East Coast when that ship was operating in full MCON mode. So it was a receive-only mode. We're talking over very limited bandwidth, and we were able to show that you can disseminate that critical information to that unit successfully. The folks on the ship were able to confirm with the folks out at the ground site in San Diego that they were seeing the exact same picture. This can also be prioritized delivery of data to make sure the most critical data is getting there. This is really about the speed of need and the speed of relevance, and again, enabling logistics platforms within contested environments. And that's really sort of where we see our niche and our focus is, again, increasing the survivability and the ability of those platforms to operate in those contested environments. So PMAT also does user interface solutions. These are a few of them that we're working on now. So Minotaur Web is operating across 3 security domains, has more than 2,500 users across those security domains. These are all micro front-end solutions, which again means they are easily tailorable and can be rapidly updated to fulfill specific mission needs. We're also, the second one there is an example of us taking sort of a traditional, highly integrated hardware software solution and then containerizing and kind of decoupling those and turning it into a thin client solution. We're also doing some IRAD around providing innovative capabilities to go to watch floors and other C2 and Intel and logistics type units, ground-based units. And then Tentacle is really interesting. This is this fifth wingman concept. The idea of this is that when you're talking about users at the edge, there's always the danger of data saturation and then becoming overwhelmed. So the fifth wingman concept here is where a unit at an ops floor somewhere can nominate critical information, and only that nominated information is sent directly to a cockpit of an F-18 Super Hornet fighter pilot. So these are just a few of those solutions. I'm going to attempt to now switch over to show you something real. It's always nice to look at something real. So hopefully this will work here. All right, so this should be sharing my screen. What you're seeing now is a copy of Minotaur Web. This is live data because of the environment we're working in. This is a DHS US Coast Guard mission that was recently flying. Just to do a little bit of orientation, where you see blue dots, that's AIS data, yellow dots is radar data, and green dots are fuse data. And then these eyeballs are full motion video. So when I talked about trying to integrate kind of JADC2 and contested logistics, the concepts that we've been talking with MSC as well as OpNav is the idea of they have this now shared situational awareness picture. If you think about it from an ownership perspective, kind of kind of think about this as a baseball card, right? So this could be someone's own ship. They pull up their ship. Of course, they've got some information about course speed, how long ago that was updated. They can see what's going on around them, including things like threats and neutral parties to understand what their overall shared situational awareness is. And then you've got these other opportunities through, other tabs, which could be something like this could be, readiness information about the crew, about munitions, about fuel, about the cargo on the ship as well. There's alerting capabilities. We also kind of have these different kind of pop out shelves and windows. This one right here is right now used for like filtering and searching, but you could also have something similar to this that would have like key logistics information. And then just kind of maybe out of interest, there's some other, map layers that you can pull, like say you want to show bathymetry and other information, and these layers can all be added and then viewed as well. So this is an example of something that's in use, by some key personnel within the current logistics community. And the concept here is that, okay, well, why don't we start to augment this by integrating that kind of JADC2 and shared situational awareness information that you've got to have in a contested environment, and then integrating that directly with key logistics information. So you can have it all in a single picture. When we go and do ops research with folks, what we found is that from a logistics community perspective, there's still a lot that's being done kind of manually, collating and pulling together and reporting of critical information, sometimes critical timeliness information. That's still a very manual process. All right, so I'm gonna try to stop sharing that here, and let's see if I can't get back to the presentation here in relatively short order. All right, so moving on into some specific AI ML work that we're doing now. So MSA Dark is a project that's funded by ONR. It is a phase 2 SIVR. And the idea of this is we are automating the identification of events of interest at sea. And we're doing so through the integration of both national and tactical data. And one of the kind of interesting things about this is that it's a series of low-level AI ML models, things like Gaussian mixture models, random forest classification, random forest regression, some business rules-based models as well. And then all those get combined into what we call a context adjustment model to come up with an automated, single recommended course of action for the users. This is a real-time application, basically ingesting real-time data and making near real-time recommendations. And really the focus is to reduce operator workload analysis and sensor planning. And if you think about a lot of the models that are involved in here, they can also apply in terms of pattern of life at sea, as well as track trajectory and some other issues like that. And I guess, is that a warning that I'm running out of time here?
John, yes, I'm so sorry. I'm going to have to stop you here. We are up
Okay.
against time, and any additional information can be shared after these sessions. One-on-one, people are allowed to contact each other. So thank you very much for your presentation, and we will now have a 5-minute break and move on to the next session. Thank you.